Hello, we're going to look at 3D coordinate geometry and vector algebra. And example 19 asks us to draw a diagram to represent the points A is -1, 1, 1, B is 1, -1, 2, and C is 1, 1, -1. So first thing we're going to do is we're going to try to draw a, a three-dimensional graph. So the way that we usually write this graph will look something like this. Trying to be neat here. Good. Where this is, I always like to point out it looks like the corner. Look the corner. Look in the corner, and you got the floor, and you got the wall, the two walls right here, and this is the corner. And this is our x-axis. This is our y-axis, and this is our z-axis. Okay. So the first point is -1, 1, 1. -1 would actually be going in the x. This is these are the positive directions for the three-dimensional plane. So this would be the negative direction this way. So that would be the negative direction. So let's see. So if I had to go -1, 1, I'm actually gonna go. Let's make that -1. I usually try to make it look like you're drawing right on the floor, and then a positive direction of 1. Looks that way, and then z is up 1, so like right there. And then what you want to try to do is try to draw, I usually draw a little box right here, and I try to draw this little box right here, and you can kind of see, try to make those lines parallel right here to each of them, and then you can see where they're at. And then you can see right here, this point right here is the point A. Good. So you can kind of see where point A is. Now for B, B is the point x equals 1. So let's see. I'll make it right about there. And then -1 for y. So it's going to be going the opposite direction, right? This way. This would be the negative direction. Y-axis that way. So it would be -1. I'll try to draw it like that. And then the z would go up to 2, right? So like right about there. So let's try to draw, trying to get that color right. Yeah, that's what I had. So here, I'm going to try to draw that box right here, right here. Doing my best to draw it. We're on a two-dimensional surface, so it's a little hard to see where it's at, but if you're careful, the points, that's going to be point B right there. And then C is point 1, 1, -1. So let's see. Z, we're going to go in the negative direction, so let's extend that. And that's our negative direction in the Z. So let's see, 1, 1, -1, right? So that's right here and here, and then we're going to go down -1 right here, right? Good. And now let's try to draw. We have this point right here, right here. Kind of see where that's at. You can kind of see right there. And you got that box, and right there's the point. So right here is my point C. So it's a little messy, but I did my best to try to draw the boxes. Maybe if I highlight them in for you real quick, right? So you got box right here. This is the box where you got point B, right? Good. And then point A was this box right here. I hope this is helping a bit, right? I got a little messy right there. That's the box right there. And then the last one was 1, 1. Let's do this color. 1. Let's try something different. Let's do the yellow one. I think the yellow will be better. And then the last one was right here. See? And that was that one right there. And that's the box that gets you point C. All right, moving on. So with let's go ahead. Well, real quick, if we were going to talk about three-dimensional planes, right? So if you have, let's say, the point A and it's x1, y1, z1, right? And point B is x2, y2, and z2, then your vector AB, just like we've drawn before, in 2 dimensions, in 3 dimensions, same thing's going to happen. x2 minus x1, y2 minus y1, and z2 minus z1, right? Good. And we can always find a vector that way. So we're going to use that to be able to solve this problem right here. So this is example 20. And it says, given that P is the point 312, Q is negative 131, and R is the point 0, negative 1, negative 1. It says find PQ in component form, then express PR as a linear combination of the unit base vectors, right? So if you remember, the unit base vectors for a three-dimensional would have been 1, 0, 0. J is 0, 1, 0. And I'll write it down here. K is the 0, 0, 1, if you remember that. So that's going to be the linear combination of that. So that's what they want from this. But first, let's do PQ in component form. So PQ in component form, it's going to be negative 1 minus 3, 3 minus 1, 1 minus 2. So that's going to be negative 4, 2, and 1. So that's that first one, right? And what should be negative 1, my bad. 1 minus 2 is negative 1. And then PR, if we're going to write it in, they want us in the unit base vectors here, right? But I'm going PR here. So that would be, I could say 0, 0 minus 3, I. And then it's going to be plus negative 1, 1, minus 1, negative 1, minus 1, j, plus negative 1, minus 2, k. And this would be equal to negative 3i minus 2j minus 3k. Good? And there you go. So that's in the linear combination form. Now, let's go ahead and look at vector addition and scalar multiplication of 3D space. This is just the same as 2D. If you have two vectors, three-dimensional vectors, U with use 1 with components use 1, use 2, use 3, and vector V with B1, B2, V3, and real number lambda, the sum of two vectors, U plus V, is in component form use of these two vectors added together, and you can write them as one vector, just like we did in 2D, and just like we did in 2D, 3D, you take the scalar product, you take some scalar times some vector U, and you get this. The 0 vector has 3 components with 0, or the null vector, and the opposite vector, same thing happens in 3D. So all these properties come out to be the same. Let's go ahead and look at an example. And it says, given U is equal to negative 2i plus 3j plus k, and vector V is negative I plus 2j plus minus 3k, write U and V in component form. So for A, in component form, this vector right here would be negative 2, 3, and 1. And vector V would be the component negative 1, 2, negative 3. Good? And then B we want to find the U plus V, then 2U minus 3V, and 3 times the U minus V. So U plus V, would be negative 2 minus 1, that's, I guess I can do this. U plus V is negative 2 minus 1, negative 3i, and then 3 plus 2 is 5j. Good. And then k minus 3 is negative 2k. Good. So that's the first one. Good. Let's look at the next one here. This time it's 2u minus 3v, right? Good? Well, what's 2u? That'd be negative 4i plus 6j plus 2k, right? And then it's going to be minus 3v. Minus 3, that would be plus 3i minus 6j plus 9k, right? And then we can add these together, and we get negative 4 plus 3 is negative I. So that adds those two to 6. These two cancel out, right? And then 3 plus 9 is plus 12k. Good, and there you go. And then the last thing we want to do is 3 times, I'm going to write it over here. And let's do this. 3u minus v, right? So 3, if I use these guys right here, u minus v, negative 2, this would be negative 2 plus 1, right? And this would be 3 minus 2, and then 1 plus 3. Good, and then this would be 3 times, this would be negative 1, 1, and 4. Or this could be written as negative 3, 3, and 12, right? If I wanted to write it as a linear combination, that would be negative 3i plus 3j and plus 12k. Sound good? Thanks.